So how do we add vectors? The very general rule of thumb is to add vectors, we put them head to tail. Now, what does that mean? Imagine you're going for a walk, and this is an example I used in 1111. And if this is not a review, if you really want to go back over this in more detail, please take a look at my 1111 lectures. We go through vector addition in much more detail. Imagine you want to go for a walk, and you walk, say, 5 kilometers east. And then you go for another walk 10 kilometers north. And you want to combine these together and figure out where did you end up from your starting point. Well, how do you combine the vectors? If you first walk 5 kilometers east and then 10 kilometers north, where do I draw that vector pointing north to the, say, in the positive y direction? Well, I put the tail of that vector where we ended up after our first walk. So I put this vector here, 5 kilometers east, in other words, say 5 kilometers in the x direction, 10 kilometers in the y direction, north. What's our final result? Our final result, or our resultant vector, the sum of these vectors, points from where we started to where, oops, that's not exactly a straight line, where we ended up. So we would say that this vector A plus this vector B gave us that resultant vector. In other words, A plus B equals C. Now, this is not to say that 5 kilometers plus 10 kilometers equals the length of this side. That's not how that works. We know actually that the length of this side would be 5 squared plus 10 squared square root to get that side. But for the vectors, we will say that the vector A plus the vector B equals the vector C. To add them together, we take the tail of B and we put it at the head of A. Head to tail. We could also walk 10 kilometers north and then 5 kilometers east, and 10 kilometers north plus 5 kilometers east brings us to the same place. So we end up in the same place. In other words, A plus B is the same as B plus A. The order of vector addition is not important. It's commutative. So A plus B is equal to B plus A for vector addition. Now, how do we determine, let's look at a more general case here. Let's imagine we have a vector A plus vector B gives us vector C. Now, we can actually determine the magnitude and direction of vector C even if A and B are not perpendicular by looking at the components. We take A and break it down. Let's say x and y are like this. We break A down into its x component and its y component. We break B down into its x component and its y component. Now, to do that, you would have to know the magnitude and direction of both A and B. So you'd need to know the direction of B relative to, say, the x-axis. But then, what do we notice? We notice that the x component of C, this length, which is Cx, is equal to Ax plus Bx. So Cx equals Ax plus Bx. And the y component, if that's Cy, Cy is Ay plus By. So that Cy equals Ay plus By. So if we have that vector C equals vector A plus vector B, then we have the same relationship between the components. If C equals A plus B vector, then we know Cx equals Ax plus Bx, and Cy equals Ay plus By. And the same would be true in the z direction as well. Cz would equal Az plus Bz. Typically, we'll just worry about two directions. Two dimensions will be hard enough for us. Very, very good. Now, what about vector subtraction? Well, vector subtraction is the same thing. We get the same result. So if we take two vectors a minus b, a minus b. Well, what does that mean? What does vector subtraction mean? Well, vector subtraction, a minus b, would be the same as a plus negative b. Well, that makes sense. A minus b, that should be equal to a plus negative b. But what is negative b? What is the negative of a vector? Well, if I take b and add negative b, what do you think we should get? Well, we would expect to get 0. Well, what can I add to a vector to give rise to 0? In other words, to give rise to a 0 vector. Well, if I have a vector b, what would I add to that to get back to where I started? Well, I would add it to a vector with the same magnitude but opposite direction. So that b plus negative b brings me back to where I started. That gives me 0. So negative b, the negative of a vector, is just a vector with the same magnitude as the original vector, but in the opposite direction. So to subtract vectors, we just add a vector that's opposite to the first vector, b, say. So if I want to say a minus b, I just take a plus negative of b, and the negative b is a vector that's in the opposite direction, but with the same magnitude as b. So let's say I have a vector a and a vector b. Well, what is negative b? Negative b would be a vector that points in the opposite direction. There we go. So I just take negative b, and then I add negative b to a, and then that will give me this vector here, which is then a minus b. There we go. Well, if we have that c equals a minus b, then cx equals ax minus bx, and cy equals ay minus by. There we go. Okay, excellent. One more quick point. How do we multiply vectors? Well, there are actually a couple ways to multiply two vectors together, but we're not going to really refer to these as vector multiplication, types of vector multiplication. We've actually seen this in the definition of work and the definition of torque. When we define work, that's actually a vector product that we call the vector dot product. And when we define torque, that's actually a vector product that's called the cross product. But we didn't actually refer to them that way. The one thing that we will take a look at is how do we multiply a scalar times a vector? So we'll take a look at just that, and then we'll be done for today. So remember Newton's second law from last semester, from Physics 1111, F equals ma? Well, over on this right side, we have m, which is a scalar, times a, which is a vector. So here we have a product between a scalar and a vector. And I hope you remember how that worked. Well, let's just think about that just for a second. Let's imagine we have a scalar times a vector. Let's just say 2 times a vector v. So what is 2v? Well, we would expect 2v to be the same as v plus v. And what happens if we add a vector to itself? So if we have a vector v and we add another vector, the same length, same magnitude, what do we end up with? We end up with a vector that points in the same direction. So if this is v, and that's 2 times v. We end up with a vector that points in the same direction as the original vector, but with a magnitude that's twice as big as the original magnitude. So we end up with a vector in the same direction, but with a magnitude that is multiplied by whatever that scalar is. What is 3v? Well, that would give us a vector in the same direction with 3 times the magnitude. What is negative 2v? Well, that would be a vector that points in the opposite direction because of the negative sign with twice the magnitude. Well, what is m times a? Well, that's a vector that points in the same direction as a, but with a new magnitude that's m times the original magnitude. So remember, that's why we said the force was always in the same direction as the acceleration, because the product of a scalar with a vector is a vector in the same direction, but with a magnitude that's now m times the original magnitude. Great. All right, we'll be seeing all of these things over and over throughout the course. Hopefully this was a review for you. If it wasn't, again, you might go back to 1111 and take a look at some of those lectures that we go over some of these things in more detail. Hopefully this all made sense. We will be seeing these things as we go along, and if they don't make a lot of sense now, hopefully they'll make a little more sense as we see them over and over again in some examples. But hope you have a good handle on this for the moment. Well, great. So that's the end of our first lecture. I hope you enjoyed it. I'll see you next time.